A warm welcome to all of you. Many thanks for joining us today for this webinar with the title Sustainable Commercial Refrigeration, a cool approach to keeping food fresh of the Cooler program. It's great to see so many people joining us on the call today from across the region and around the globe. Thanks to all of you for making the time to be here with us. My name is Alexander Pohl. I'm a senior consultant at Guidehouse, and I'm supporting the CoolUp team as an energy efficiency and sustainability expert. To celebrate today's World Refrigeration Day, we will discuss in this webinar how sustainable commercial refrigeration can play a role in upscaling sustainable cooling in the Middle East and North Africa region. Let's have a look at today's speakers. For the discussion, I'm joined today by Nation Sirmali Anaj. Nation is the Cooler Program Manager and Associate Director at Guidehouse. Nation focuses on aspects of sustainability in the built environment, both on buildings and building products level, with a strong multidisciplinary background. She currently leads the implementation of the Cooler program in our 4 partner countries, Egypt, Jordan, Lebanon, and Turkey. Our second speaker is Barbara Geschrei from Öko-Recherche, who has been working on the Montreal Protocol and the F-gas legislation for more than 12 years. In our Cooler program, Barbara supports us as a policy expert. Our next speaker is Olaf Schulze, who is the Director of Energy Management, Real Estate Sustainability at Metro. Mr. Schulze has been engaged in energy management at the F-gas exit program since 2014. And last but certainly not least, Firas Abdin. Mr. Abdin is a refrigeration engineer who has been active in developing the company Abdin Industrial for more than 30 years. Abdin Industrial is a leading manufacturer of supermarket and kitchen equipment with project references throughout the Middle East. So without further ado, let's get started. Before we dive into the content, let's have a look at today's agenda. In the first part of the webinar, Nation will give us a quick overview of the Cooler program before Barbara will dive deeper into sustainable commercial cooling and discuss the learnings and experiences from EU perspective and the role of natural refrigerants globally. In the second part of our webinar, our guest speakers will present 2 practical examples. Mr. Olaf Schulze will talk about the work he is doing for the F-gas exit program at Metro, and Mr. Firas Abdin will present a showcase of a supermarket in Jordan which uses natural refrigerants. We will conclude the webinar with an open Q&A session, and I would again ask you to use the question window of GoToWebinar. And only organizers will see your questions. So without further ado, let's get started, and I will hand it over to Nation to kick us off.
Thanks, Alex, and greetings to our participants. My name is Neshan Sürmeli, and I'm the Program Manager of CoolUp program. I'm happy to introduce our program today, and I think we can switch to the next slide. Thanks. CoolUp program is funded by the International Climate Initiative of the German government. Our program started on December 2020, and it's going to run until January 2027. The long duration of the program gives us opportunity to really focus on implementation measures and create an impact in the countries that we are working on. We focus on upscaling sustainable cooling and refrigeration in the region. In essence, globally, we face a range of energy challenges against the visible effects of climate change due to rapidly growing urbanization and heavily strained energy infrastructure in many regions of the world. This is particularly the case in MENA countries. In the region, cooling and refrigeration constitutes a major source of energy consumption, and it is expected to grow further. CoolUp program promotes accelerated technological change in early implementation of cooling in Kigali, early implementation of Kigali Amendment and Paris Agreement in our partner countries. Next slide, please. COOLA program works in 4 action hubs in the MENA region. In general, in the region, the countries face similar challenges like rapidly growing cooling, refrigeration, and final energy demand, and structural energy sector challenges. Our teams developed country-tailored solutions for our 4 action hubs and facilitate information exchange between those 4 countries as well as within the MENA region. Our program aims to add to the ongoing efforts for increasing efficiency of appliances and buildings and bridge the world for climate mitigation and adaptation in order to deliver on several work areas and work streams that we are working in COOLA. In the next slide, we will have a look into our consortium. In order to cover several aspects that we have in the program, our consortium is formed by multiple organizations bringing in their specific and unique expertise. Guidehouse is the leading organization for the COOLA program, in addition to bringing in technical expertise in all aspects of the program implementation. We have a co-research, Barbara, with us today, who's going to be presenting in this webinar to share their expertise. COOLA is represented by our national partners in each partner country, who makes sure that the implementation of the program is well embedded in the current national regulatory, financial, and market landscapes. And UNDP and RIGRI facilitate knowledge exchange, and the learnings are multiplied and shared with the broader regional outreach. In the next slide, we're going to look into the components of the program. COOLA has a cross-segmental focus, working on refrigeration and air conditioning in commercial sector and air conditioning in residential buildings. We exclusively focus on solutions that are energy efficient and with natural refrigerants or in-kind solutions. Our aim is to bring together different worlds, efficiency and refrigerant, so-called climate change and protection of the ozone layer. We have a holistic approach across the value chain that starts with demand reduction. This is mostly relevant for cooling, and Hfc Phase Down, replacement and safe disposal, training and awareness, and improved cooling appliance operation. We realize that the accelerating transition to sustainable cooling and refrigeration requires a multi-level and multi-sectoral view. So COOLA program works with a holistic approach that is based on 3 main pillars. The first pillar focuses on providing regulatory support to partner country governments for implementation of Paris Agreement and Kigali Amendment objectives. The second pillar focuses on the role of financing sector. Throughout the program, we work with financial institutes, national and international financing institutes, to develop financial models and business models to boost sustainable cooling and refrigeration market. The third pillar considers the industry and market players and the technology development. Our work focuses on using the technical knowledge that the manufacturers and service providers and the actors on the value chain, on the supply chain in the refrigeration and air conditioning sector, and extend this knowledge from international practices that use sustainable cooling and refrigeration solutions. Within our work package, we focus on developing the technology options that are suitable for every country climate, and also work with demonstration projects that showcases real-life examples for the implementation of energy efficient and natural refrigerant solutions. We put a high emphasis in working with our stakeholders from all these 3 pillars, and have an approach to serve as a platform that brings key decision makers together. This is also supported by the technical capacity building that COOLA delivers for all stakeholder groups. And additionally, last but not least, we work on the dissemination and outreach on national and regional and international level. And this webinar is one of those activities that we value so much, where we bring in real-life examples and also theoretical knowledge to the participants. So thank you very much. I'm really looking forward to hear our experts today, and back to you, Alex.
Thanks, Nation, for that overview of the COOLA program. Let's hand it over to Barbara, who will tell us more about the sustainable commercial refrigeration sector and her experiences and learnings from EU perspective.
Thank you, Alex. Thanks for having me today. So initially, I would like to give a little bit of an overview of the commercial refrigeration sector. There are generally 3 types of systems that are distinguished: centralized systems, condensing unit, and the standalone units. Those differ by the capacity ranges that are relevant for the system. So the typical supermarket system or larger system in warehouse would be a centralized system. Also, the leakage rates are typically differing between those systems, and the aspect that is very relevant for the CoolUp program is the refrigerant. So in the middle column here, you can see that different refrigerants have been used in the past and are still around in old systems. So typically that's R22. Then also common refrigerants today in many parts of the world still are R404A and R134A, whereas newer systems are running on blends containing HFOs or also on CO2. If aspects touching on the efficiency of the systems are listed in the further two columns. So those aspects are relevant and are in scope of the CoolUp program. We are looking at both refrigerants as well as energy consumption. Next slide, please. In the CoolUp partner countries in the MENA region, we can observe that the standalone units are used predominantly, and this is a very typical situation when a lot of small corner shops, family stores are available in the countries, and the use of these plug-in systems is very common. Centralized supermarket systems are less common. They can be found in urban areas and urban centers mainly. And condensing units are also very common for smaller cold stores and in restaurants. HFCs are dominating the market, as mentioned earlier, and R22 is also still around in existing equipment. We observed that in the partner countries of the MENA of the CoolUp program in the MENA region, some experience with natural refrigerants in commercial standalone equipment is already available. So we have experience with R290, but also in the domestic refrigeration sector, some companies are working with R600A already. Furthermore, it should be mentioned that the supply chain of components is relying heavily on imports in many countries, and that's particularly relevant, of course, for the centralized systems. Regarding energy efficiency, the equipment that is installed currently is typically less efficient than the best available technology. So we can see that also a big potential is around in all these countries to improve energy efficiency and save energy. Next slide, please. An important development lately in the region needs to be stated, which is the ratification of the Kigali Amendment. So we have several countries that ratified the Kigali Amendment already as of today. So we have Morocco, Tunisia, Turkey, Jordan, Lebanon, and that of course will impact also the trade connections between countries, as well as the availability of alternatives. Big questions that are related to this ratification of the Kigali Amendment is, of course, also linked to uncertainties. So we are wondering, how does the Kigali Amendment link to the ODS phase out? That's two challenges at the same time, basically. And also the future availability and prices of HFCs and potentially also HFOs is not so clear at this point in time. A question that has been around for a long time and still needs work in many places, we believe, is the technical feasibility of alternatives to HFCs. And then, of course, also a big question, will it be possible to maintain or also to improve the food supply chain in view of these challenges that are stemming from the ratification process. As you can see in the little table on the right, at the moment we are still in one of the baseline years for the phase down schedule of the Kigali Amendment. So the freeze year, where a baseline level of 100% needs to be kept, is the year 2024. And then the reduction steps will follow from 2029 onwards. Next slide, please. So to sort of help answering these questions and to overcome the uncertainties, it's important to have a clear vision of what should be achieved in the future. And sustainable cooling is seen as the key solution in the CoolUp program. And this slide tries to illustrate what it means. What is sustainable cooling? And in our view, this relates to the vision of zero carbon technologies. So the use of fluorinated refrigerants should not take place. Systems should be showing high energy efficiency, and also the use of renewable energies should be employed. Next slide, please. And since this situation in the MENA region we are currently seeing is actually not so different from what the EU was experiencing in the past, I put together a couple of points here that can serve as maybe experiences and lessons from the EU. So back about 20 years in the past, in the EU, there was growing concerns about the high refrigerant leakage rates and high energy consumption. And that was particularly linked when it came to the phase out of HCFCs and especially R22 back then. Also back then, the documentation led to clearer benchmarks and the identification of saving potentials. And then in 2006 in the EU already the first F-gas regulation entered into force, and that set out measures to reduce leakage, including technician trainings, leak checks, the documentation of repair and maintenance activities at the systems. So that was a big step to improve the basis of data and information. And then since 2014, a revised regulation entered into force, and this regulation set out the EU Hfc Phase Down, which does not only include the phase down schedule, but it also includes a number of bans for high global warming potential refrigerants, not only, but also in the commercial refrigeration. So it's a combination of these factors. And that resulted in a strong price increase for HFCs and throughout the market, a push towards low GWP alternatives. And the commercial refrigeration sector was very much involved in the implementation of the new regulation since then. A lot of research and development has also been taking place to develop technical solutions using natural refrigerants and improving the energy efficiency for various store types in commercial refrigeration and all applications basically, so that we can see today a good availability and also competitive prices of natural refrigerant solutions. It should also be stated that R744, so CO2, is very common in centralized systems in Europe today, and R290 and R744 are also very normal and widely used in standalone equipment and condensing units. Next slide, please. So regarding these price increases, I can show here a slide on the price development of HFCs at the service company level, which would be most relevant to end users such as shop owners and supermarkets. So we have price information starting at 100% back in the year 2014. And this graph is showing the index. So it shows the percent increase since then. for common refrigerants. And the red curve is most relevant here for R404A because it also has a very high global warming potential. And as you can see, there were some price peaks back into early 2018. And the price has been dropping since, but also the availability is widely reduced, and still the price never came back to that level from 2014. So we have today, still an increase of several 100%, and it is anticipated that this experience will apply also in other countries as a consequence of the ratification of the Kigali Amendment. So it's about time to search for alternatives and to actually bring them to the market and employ them widely. Next slide, please. Yeah, and then we can also see here that the commercial refrigeration sector has been taking the lead. So it was found, of course, extremely important that solid technical solutions are available to maintain the cold chain and to secure the food supply throughout the commercial sector. And then also the cost considerations in view of rising refrigerant and energy prices have been a key driver for the private sector to look into sustainable solutions. Also, as a consequence of the F-gas regulation, an increase in compliance costs for larger HFC systems was mentioned as a driver. So all this documentation and record keeping and monitoring and being readily available for inspections when someone from authority comes, that's of course a cost that companies need to factor in, and it can be a counter argument when it comes to choosing a good option for a new supermarket or a new warehouse. Yeah, and then a very big role in my view is also the private sector engagement in terms of sustainability policies and climate pledges. So very well known is the Consumer Goods Forum's pledge back in 2015. And I think that I also got in touch with Mr. Olaf Schulze from Metro back then already, and it was a very interesting experience to hear about the important role and the momentum that has been created at private company level back then, and which has been carried on since. Some frontrunner companies were around early on, but I think in the EU nowadays there are no frontrunners anymore, but it has really become mainstream, and that is illustrated by the graph on the right-hand side. So you can see here the number of the transcritical CO2 installations in Europe in the period 2008 to 2021. So early years we've had like a small number. There was like more pilot installations, testing. It took a couple of years to have the technology adopted to different conditions and to check on the best options. But then you can see from 2015, when the second F-gas regulation came into force, having the Hfc Phase Down established and also the bans for commercial refrigeration sector entering into force, there was like a very, very big impact on the market. Since then, basically, the numbers of installations have been growing every year. And we can probably follow a similar development in a few years in the MENA region. I'm quite convinced that this is replicating. And in view of that, I think we can get good examples and a good understanding of important milestones and important initiatives when looking more closely into the practical examples that are following. Thank you.
Thank you, Barbara, for this overview of the commercial refrigeration sector and sharing your experiences from EU perspective. We will now get some insights of a practical example from Metro. Mr. Schulze, the floor is yours.
Yeah, thank you very much. You all, thank you to be today part of this webinar. My name is Olaf Schulze. I'm working as Director for Energy Management and Real Estate Sustainability for Metro. Metro is a wholesale company. We are selling food and comparable non-food segments to hotels, restaurant caterers, to traders, and we are active in 23 countries of this world with our brand Metro or Macro. We are operating 700 stores and depots. By the way, in this business, our direct supply, our food service delivery is strongly increasing. And the second big brand that we have is Classic Fine Food, operating in 10 countries, for example, also in Dubai, Vietnam, China, Japan, Indonesia, Switzerland, and UK, for example, and where we are selling to special restaurants, special food. And in the end, dear all, nothing will be by coincidence. Perhaps you can go to the next page, please. Yeah. The next one. Wonderful. Nothing will be by coincidence. We need cooling as our technical backbone to operate our business, because we are selling and we are operating with food, with fresh, with ultra fresh, with meat, with fish, with fruit and vegetable, with dairy products. Therefore, we need cooling as our technical backbone. And the second, Barbara said it, energy. And therefore, the energy manager is responsible also for this business to operate. In the wider sense, the cooling equipment is one of our ingredients, what we need to operate our cooling equipment. And energy has minimum 2 problems, in between 3. The first one are the cost, the second are the emission behind, and the third in between is the availability. And the main driver to execute, to construct, to refurbish existing cooling equipment is the end of life cycle of the existing equipment. But the second, the pressure, and Barbara presented it, the pressure from the legislation, and then we coming as employees, as customers, as society. We are living in this planet, and cooling equipment is responsible in our business for near 50% of our energy electricity demand, and the second, more or less 20% of our emissions are coming by the refrigerant losses. And we have one big target, one big mission. In 2040, we as Metro, in our 24 Metro countries and 10 CFF countries, like to be climate neutral. We like to operate with 0 emission worldwide, our business. And how we like to approach it? We like to reduce very strong our electricity demand, our energy demand, with the energy saving program. The second, and later I will explain it very briefly, the F-gas exit program, the step out of the usage of the HFCs, and by the way, the HDFCs, we stepped out in our operations in years. The third is the photovoltaic program. We like to produce the energy what we need, especially at our store by photovoltaics. Then the rollout of Green Store and Zero Emission Store. Green Store is a big refurbishment, and Zero Emission Stores are the new stores. They should be either nearby 0 today, or 0 or positive, carbon positive, when we have a new store. By the way, we're operating until now only 1 store. It is located in Austria, in St. Pölten. And the new measures, they are part of our 2040 target, is a heat exit program. It is framed because we like to use the waste from our heating systems to operate our water and heating system, especially in the northern part of this world, and in the far end, the decarbonization of the company fleet and of the green logistic. When we could go to the next page, I can tell you I'm responsible for the business since 2005, and in 2013 we started our strategy, the F-gas exit, the step out of the usage of the fluorinated gases in our cooling equipment. And by the way, when we like to be in 2024 with climate neutral, after 2030 at least, I have to rebrand the F-gas exit program in an exit program to come to higher performance and higher energy performance and higher environmental performance. Our first transcritical system, a store that is operating only with natural refrigerants, we built 2008 in Hamburg in Germany, and by the way, at least in 2028, then we will refurbish existing transcritical system to transcritical system on a higher level of efficiency of performance. What means F-gas exit program? It means in all new store openings, in all refurbishment worldwide, we like to use only natural refrigerants. In accordance with the life cycle of the existing equipment, we are not stupid, we are in a business, we are in a strong competition as wholesaler. When the life cycle of an existing equipment ends, then we like to install only new equipment that is operating with high energy performance and with natural refrigerants. And by the way, we are focused mainly to transcritical cooling equipment, to CO2 equipment, and to propane solution. And in the storages where it is possible, we are operating also with ammonia. So full focus therefore is to transcritical cooling technology, and by the way, this ejector that we can use is also in this case a little bit to waste the higher temperature to operate our equipment, and that we can go more south, more in the warmer climate area to operate such technology. And we like to connect it, I mentioned it in the page before, with a heat recovery that we can use the waste to heat our water or to heat our stores. By the way, when I'm speaking with our engineers, and by the way, I'm a lawyer, I'm not an engineer, but I'm a lawyer with an engineering background, they are saying, Olaf, we can install, when you like, overall in this world, natural refrigerants, but I mentioned we are in business, therefore I have to say, F-gas exit means natural refrigerant in all stores where it makes sense and where it is technically possible. Then I have, in the case of repair or in the case of maintenance, to hire a Galaxy airplane to bring somebody from California or China to our stores, then it makes no sense. Therefore, dear listener, what we need is a collaboration and cooperation with the refrigeration industry, with the installers, with the handcraft companies, that when we installing transcritical and also natural refrigerants, then we need also during the life cycle of such equipment the right maintenance and repair capacities. By the way, also we have small repair solutions. Small repair means usually our deep cooling has leakages, we have problems, then it makes often not sense to refurbish the whole store. Therefore, we are often focused to smaller exchanges. Then we installing the plug-in solutions, the propane solutions. We did it in the past in Germany, in the Netherlands, but also, for example, in India, in Pakistan, in Kazakhstan. And clear, as member of the Consumer Goods Forum, we are contributor and full focused to our refrigeration solution. We will be, and Barbara mentioned some example, in our business front runners. We will be part of solution and not be part of the problem. But the problem is not the refrigerant as such. The problem is the leakage when it goes in the atmosphere. 1 kilogram R404A, Barbara mentioned, it has a climate impact of 3,922 kilogram CO2. The global warming potential on monthly level, we in Metro, we are motivating our colleagues in the countries, in the stores, to reduce the leakage, to be aware. And here you can see one benchmark is a real KPI that we have on monthly level, clear of course also on yearly level. It is a leakage rate. Here is very warm, very actual, the status of May. Our target for this fiscal year would be 8.4%. And in May, we achieved 7.4%. It was the first time since years, since the beginning of this KPI, that we could go below the 8%. And from left to right, you can see more or less all of the countries. We have favorites like in Slovakia. Favorite is a little bit sarcastic. We are only operating 6 stores in Slovakia with 20% leakage rate, 21%. It is not good, we know it. Therefore, this year we will have one refurbishment. 6 stores we have. One is operating with transcritical system in Kosice. This year we will exchange the next one, next year too. It means end of calendar year 23, 4 stores out of the 6 are operating with transcritical CO2. So with CO2, then Slovakia will go on the left side of the bar. And for example, Austria, where we are operating also some stores, subcritical or transcritical, we have in traditional the lowest leakage rate. And one reason is also, when I'm looking to Austria, it is not only the installation, it is also the operation, the maintenance and the repair. But we could go to the next page. In few words, it has been our F-gas exit program. What is the progress? 40% of our stores are ready for 2030. It means they are either operating only with natural refrigerants or with refrigerants with a global warming potential below 2,500. The status is, it is a nice figure. We have 222 stores. They are operating now with net refs. Therefore, or they are off 153 transcritical system, 69 subcritical. Subcritical, by the way, it is coming from the time where we were a little bit testing and looking. We have some of such stores in Poland, in Germany, and other countries, also in Austria, as I mentioned, and 15 stores or depots are operating with ammonia or propane. And also, it is a part of the trueness. Often, we have stores, they have no leakage problem, but we like to reduce in general the global warming impact, and then we did retrofits. 58 retrofits means we exchanged the R404A or the R422A to a refrigerant what is below 2,500. And very important in the progress report is that we have to connect it with the heat exit program. HEP is an abbreviation for heat exit program, that we are using the waste heat for heat recovery, or we connecting the store equipment with heat pumps, and especially when we are looking in these times where we have in a lot of countries, in Hungary, in Austria, Slovakia, Germany, Poland, Czech Republic, really the risk that we are not connected to enough gas, then heat recovery could save our stores, that we can reduce very strong, very dramatically the gas demand, and in the end reflects to my first page our carbon footprint. And what is the outlook? Outlook is really very interesting. We are here with focus to MENA. I'm so happy in this year, in 22, we started the construction of our first transcritical system in Turkey, in our wholesale store Metro Antalya. We will install the first transcritical system in our country. In Turkey, we are operating 30 stores, more than 30 stores. And for next year, I can announce we will start with the next 2 stores. And therefore, in the next years, until 2030, in the end, it is our aim, it is our target. We like to execute all existing cooling equipment to more modern, means high energy efficient, good in best standard in good presentation, and only operating with natural refrigerants. Therefore, white spots of transcritical system will be solved. We have the first installation in Turkey, and for next year we will close our first system in the Republic of Serbia. Our focus, dear all, it is very important when you are from the industry side, is to standardization and harmonization. We have here a project Iceman, clear. Everybody is, for example, driving with a diesel or with an automotor, but in the end, we will be focused to better standardization and harmonization in technology. In the front, the cooling furniture, the good presentation, it can be adapted to the local demand, to the local market, but the technology behind in the machinery room, it should be more or less worldwide standardized and harmonized to come to lower cost, to better repair, to better maintenance. And in the end, also leasing or refrigeration as a service, we say premium service packages is a topic. Therefore, be stimulated and motivated when you are from the industry to training your people, because we as wholesaler are coming in the countries. We like to go to F-gas, to be F-gas free, and in the end, that we can collaborate, cooperate, and successfully together operate our stores and our cooling equipment. A part of the trueness, dear all, is, and I mentioned it, before, we are in the competitive world. Sometimes it is impossible today economically to operate transcritical systems. We need you, we need the industry for the installation, we need maintenance, we need repair, and therefore it could be that in some countries, and here as example in India, in Pakistan, or in one small depot from Classic 5 Wood in the United Arab Emirates, we installed with a conventional technology, but conventional technology with a global warming potential below 2,500. The most used refrigerant is R448A, and in the end we are looking for the overall efficiency. Last page, please. Wonderful. Then I can summarize you all. We as Metro, we are on the way to be F-gas free, to not operate, so we are not operating HTFCs, we will not operate anymore HFC tetrafluorocarbon. And Barbara mentioned also the magic HFO. We have one store in Brno in Czech Republic where we installed HFO, but only one. We stopped this trend. The HFO has low GWP, but has also disadvantages. Therefore, we decided for us, we are focused to transcritical systems. We are focused to propane. So far, it is possible ammonia, and we like to invite you to accompany us, like we are doing in Turkey, that we will go to HFC free environment and operation in our stores. Thank you very much.
Thank you, Mr. Schulze, for this practical example on commercial refrigeration from your perspective as director at Metro. In case there are questions to Mr. Schulze, I would remind you to please use the question window and go to webinar or the chat window. We will have a Q&A session in the end of the webinar. To gather even more insights of how commercial refrigeration is used, I'm excited to hear now Mr. Firas Abdin presenting another practical example of the work that is happening at Abdin Industrial.
Thank you very much. My name is Firas Abdin. We have a company in Jordan where we produce all kinds of commercial refrigeration for supermarkets. Our main market is the MENA region, Gulf region, and North Africa. Can you go please to the next slide? I would like to make a brief introduction on the system, and then we will see the system layout, and then we will compare between a new and old system which we have done in Jordan. Of course, we talk about the CO2, the new system advantages against the old system, and the measure system performance and energy demand. Next page, please. The system which we have done in Jordan for a supermarket, it's a governmental-owned supermarket, and we were the first company to install the first CO2 transcritical system in our hot ambient countries in the Middle East and the Gulf region and North Africa. The system was installed in Amman in January 2008, and it's been performing excellent until now. The project was funded by the Climate and Clean Air Coalition, implemented by UNIDO, and installed by Abdin Industry of Jordan. Next, please. This is just to show the system layout and type. This is a transcritical CO2 system with ejector supported with parallel compression, and as well we have a non-superheated operation of evaporators. So we flood the evaporators with liquid CO2 to get the highest performance and the less energy consumption. Can we go to the next page, please? I would like to compare the old system with the new system which we have installed. The old system have 22 linear meter of open chiller, and the new system will have a 35 linear meter of closed door chiller. The height of the chiller of the old system is 2 meters, and the new system is 2.22. The frozen, they used to use an island open freezer with a 12 meter long, and the new freezers are vertical door freezers with 32 meter long and 2.2 meter height. They didn't have a cold room or freezer room. In the new system, we have one freezer room and 2 cold rooms. Cooling capacity of the old system was 30 kilowatt. The new system have a 31 kilowatt of cooling capacity in the positive. And on the negative, we had a 10 kilowatt, and in the new system, we have 38 kilowatt. So actually, we have more than 60% of extra chillers and more than 400% of extra freezers to be displayed. And now we can see how much energy we were able to save even with such bigger freezers and chillers. Can we go to the next page, please? This is which show us the layout and the type of the chiller which were used before the upgrade. They were in that supermarket, they were using open chiller and island freezers. Both are, of course, are opened with a limited product being displayed in the supermarket due to the limited number of chiller they had at that time. Can we go to the new slide, please? Next one. In the new upgraded system, we have used door chiller and door freezer, and if you can see that we have now in both sides of in the supermarket our new chillers, and we can see the island frozen with a large capacity of displayed products. And as well, if we look onto the right side of the screen, we can see the cold rooms. We can see the 2 cold rooms and 1 freezer room, which there was not present before. Can we go to the next slide, please? Now we can see the advantage of the new system against the disadvantage of the old system. In the old system, we had a limited display area for the food. In the new system, we have 60% increase in displayed food variety, especially juices and soda drinks, where in the past our customer was only selling dairy products, and there was no space to display more products to increase their sales. And in the frozen, we have increased more than 400% the displayed food. In the past was only limited on some poultry frozen product they were sold in the supermarket. The old system, we have a high food wastage. In the new system since 2018, and according to our customers, he did not waste any food, and that of course due to the stable temperature of the system, and as well of the breakdown. The system has never broke down since the day of installation. The old system has consumed high energy. Our new system consuming low energy. Old system have high and continuous gas leak. The new system, no gas leak at all. The old system, they used to have a low sales volume. In the new system, they have high sales volume. That's due to the increase in the capacity of the chiller. In the old system, they have a high maintenance cost. In the new system, until of today, they have a zero maintenance cost. We do a regular visit to the system to clean the gas cooler, because Jordan has been a dusty country, and the gas cooler gets blocked with the dust. So we just, the regular maintenance we do is just only cleaning the gas cooler from dust. So by using transcritical with a high technology and a durable and reliable system, we're not just saving energy, we are saving food wastage, and this is a cost for the supermarket owner. We are saving energy more than 30%, maintenance cost as well, and as well we are increasing the profit of the supermarket by using a larger capacity chiller and consuming less energy equipment. And this is what we are actually trying to convince most of our customers in the region, is to switch from HFCs into natural gases such as CO2 for centralized system, or using for the plug-in chillers our new innovated chillers running on R290. We have just completed a new innovation of various types of chillers which will consume a maximum 300 watt hour. We have just completed one big project for a Giant supermarket in the UAE market with more than 28 chillers, vertical, full height, vertical, low height, and serve over chiller. And the total consumption of this supermarket every day of energy is around 25 euro, which is nothing for such a big supermarket. So we are pushing now two new technology into our market. We are pushing the CO2 and the R290. Actually, we're not just pushing to sell, but we are educating our people. Since most of our customers in the region do not know about CO2 systems, do not know about natural gas system in general between CO2 and R290. We are taking a big role of educating and improve their knowledge, as well as educating technicians. Technicians and engineers in our part of the world, they don't know much about such technology. So our role is as well to create a small school where we can teach and upgrade the level of our technicians and engineers in the MENA region and Gulf as well, and North Africa. This is our main markets, and we are trying to increase the level of knowledge of our customers. Can we go to the next page, please? Here we show the energy demand or the energy saving which we were able to obtain with our transcritical CO2 system, which is an average of around 30%. We can see in March, April, May, or in the month where is the temperature not so high, energy consumption where we able to save around 20%. And in the summertime where temperature goes high, the system will save. We can see that the more energy is saved. Of course, that's because of using the ejector technology in the CO2 system. And ejector performs much better with a high ambient temperature. And this will demonstrate that a CO2 system can operate in hot climate countries, not just in north or central of Europe, where ambient temperature are much lower than as in our part of the region. And as well here we demonstrate, even we have enlarged the chillers, the capacity of displayed food, we can still save a lot of energy. So if we compare both systems, if we take the same capacity of two systems of CO2 and HFCs, we will see that the CO2 could save more than 50 to 60% of energy in our part of the world. So we are trying to push and recommend the system more and more in our region. Can we go to the next page, please? And here we have, this is a live data of energy demand in the supermarket. If we can see in 2017, where before we installed the CO2 system, energy was high consumed in the supermarket. And after installing the CO2 system, we start taking some readings from February to October or November of 2018, and as well all throughout August 2019, and we can see clearly the energy reduction in summertime and energy demand in the supermarket. And this is a convincing point which we always use to try to convince new customers to go into the natural gases, and as well to protect our environments and to have a clean environment, clean air in our countries. Please, next slide, please. So to summarize our seminars, or our to summarize it, so our first CO2 system booster with ejector supported parallel compression installed and high ambient temperature in the country, as in operation since January 2018 without any problems. The feedback from our customer: up to now, operation without extraordinary maintenance visit, no failure in the system nor the cabinets, zero food wastage due to stable temperature level in the display cabinet, and as well, since our customer displays also fresh food, we extended the shelf life of the product as well. So we extended the shelf life of the product. He does not waste any food. Reduction of energy demand on the refrigeration system more than 30% compared to the HFC systems. And of course, we have increased, or we helped our customer to increase his sales and profit margin as well in the in his business. Next page, please. We thank you for your attention, and if there's any question, be happy to answer.
Yes, thank you, Mr. Abdin, for this great example from the region. It is super interesting and insightful to hear about real-life examples. It really shows that the technology is already available today. Let's spend the remainder of our time together answering questions from the audience. I would ask all speakers to turn on their cameras, please, and unmute. I'm just looking through the questions. I think we already have some questions here, and the first one would go to Barbara, I think. Barbara, what further activities on the commercial refrigeration sector will be done in the cooler program?
Yeah, it was mentioned earlier that the commercial refrigeration sector is one of the sectors in scope of the cooler program. So we will be hosting and organizing different events, such as also in this year still a regional conference where some attention will be given to the commercial refrigeration sector. We will have a number of publications coming soon, and I believe that that's still part of the outlook at the end of the event. We will have technical solutions reports. We will have publications on the market status, and also the cooler program entails a component dedicated to training. So maybe there is even a potential to cooperate with Abdin further in this field, and that's there will be technician trainings and possibilities to improve the skills of technicians working in the service sector.
Great, thanks so much. There is another question I see here from Mr. Schulze. What are Metro's further plans in the MENA region?
Yeah, thank you for the question. Also, I mentioned it in Turkey as part of MENA, where we are very active. We are starting now with Antalya 1, with our first store, but we like to convert from 404A to transcritical system. Next year, we will have the next 2.1. And then also in 24, 25, every year we like to roll out our F-gas exit program, that we can also say end of this decade, 2030, we are free of F-gases, but in addition, my first page was a Metro zero emission strategy. Also in Turkey, we investing not only in cooling equipment, we investing also in new, for example, LED illumination in the store. We like to reduce very strong our energy demand. And what we are really doing in Turkey, we will install more or less top on each roof photovoltaics, that we can reduce our energy by, like Mr. Abdin, with new cooling equipment, our energy demand, with new illumination, our energy demand, and we like to produce not only a small quote, a bigger quote of the demand that we have by photovoltaics top roof, that we are more and more near zero. But 2030 is only the half time. 2040 is the end time, and you can imagine to come to zero emission, we have to do a lot. Then illumination and new cooling equipment is not enough. But more or less, you can say Antalya is now our first store, the pilot. And usually after 15, 16, 17 years, we have refurbished again. Therefore, I believe that before 2040, we will install then the next generation of cooling equipment in the store, what we equipping now with ejector technology, transcritical, like in Antalya.
Yeah, interesting. Thanks so much for the answer. We have several questions here. The next one would go again to Mr. Abdin, if you don't mind. The question is there any interest in Jordan or other MENA countries for more transcritical systems?
It's a good question. Actually, I would have to answer in a very honest way. Actually, at the moment, there is no demand on transcritical systems, on CO2 transcritical systems. But we are trying to create the demand of the customers. And the reason there is no demand, people are afraid to use the new technology, especially, as I mentioned earlier, that there is no qualified technicians and engineer to take the responsibility to carry on the maintenance and after sales service of the system. Okay, in our company we have, but we have 4 or 5 people. We cannot run across the whole region to support say natural gas system. As well, there is no rules and regulations. For example, in Europe, they have banned the use of HFCs, where in our part of the world, we still have until 2045 or 2048 are allowed to use HFC. So if our government do not move and do some new rules and regulation to stop using these HFC gases, people will still use it until they are totally, completely banned. And you will be surprised that we still get some customers asking for R22. And we say it's impossible nowadays to have R22, but this is due to lack of education in our part of the world. Our schools, our technical schools in the MENA region, in the Gulf, in North Africa, they're still teaching the old refrigeration technology with R12 and 502, and they never speak of a new DC inverted technology in new types of gases. So basically, this is a problem. Second one, our part of our market, the region are price-oriented market. So when you come with a new technology, of course, a new technology always have a higher price than the standard technology. So people are not willing to invest in a new technology, especially when you will have to pay 2-3 times higher price than a standard CO2 system than a standard HFCs. So if we don't have rules and regulation implemented by our governments, people will never convert into the new technology. But we are, as Abdeen, we are trying to play a big role in the market by convincing the people, or trying to introduce technology which suits the budget of our customers. For example, now we are doing we are converting most of our plug-in chillers into R290 with a DC inverter technology to try to reduce energy as much as possible. And as well, we have invented a new system, a new DC inverter scroll compressors. We are making a centralized system of this running on R448A, which is with a low GWP gases. So we are trying to do as much as possible in our region. But if we don't, as I said, if we don't get support from our governments, we will continue with the old technology, unfortunately. And one very important as well reasons, for example, in Jordan, in Jordan, when we speak to our customers, we speak to the owner of the supermarket, where we can convince him to go into new technology, and he take a decision. And let's say if the system doesn't work, the owner took a decision, so nothing can happen. In other part of the region, like in the Gulf region, usually we don't deal with the supermarket owner or with the high-end management. We are mainly dealing with a purchasing manager or a project manager. And we speak and talk and explain and convince. You're talking really nice. We are convinced, but we want to stay with the traditional system. Why? Because if the new system doesn't work, we will lose our job, and we don't want to lose our job. So we want to stay with a standard known system which has been tested for many years. And if we come to the Gulf region, the idea here, a chiller must use a hermetic condensing unit with a very high energy consumption. Freezers or low temperature application, semi-hermetic compressor, full stop. You go to a supermarket with 20 cabinets, you will see 20 condenser units hung on the wall, each cabinet fed with a single compressor. And this is where energy consumed are very high. Now, I have been in Dubai for the last 2 years, living actually spending most of my time here in Dubai. And we have started slowly to change the idea and to prove to the customers that a new technology, okay, using the low GWP gas like 448A, can work, can save energy, and as well we can start to protect the environment in the countries to have sustainable energy. And then we slowly start to convincing the customers on using a plug-in chillers with R290. In the beginning, wow, this is flammable, our shop will be burnt out, we do this and this. No, and then we show them it's not. The system is so reliable. The components are used. It's a high reliable, durable equipment which can run without gas leak, without anything scary to burn down the supermarket. And I always told to my customer, I said, our chiller has maximum around 150 grams of gas charge, but at your home, in your kitchen, you have a bottle of gas with a 20 kilogram sitting in your kitchen. This is a bomb. Not the chiller in a supermarket with 150 grams can cause a fire, a hazard into your supermarket. So slowly, we are convincing. It takes time, but we will never give up. And we need our part of the world to be green. And we need to push our new technology. And I have one of my son, now he's doing a master's degree in CO2 refrigeration system in Norway. So we want to push more and more this technology, this idea, educate people, not just sell and make money, but we really care about educating our people in our part of the world.
Yeah, thanks so much for this answer. I think we have a nice question that is a little bit connected to the question that Mr. Abdin just answered. It goes to Nation. What are the key hindrances to the adoption of these more energy efficient systems in developing countries? Is the issue upfront costs? Is there a need for policy change promoted by the public sector?
Yes, thanks for the good question. And I think Mr. Abdin has already outlined the challenges that we see in the developing countries in the region, but also I would say in many other parts of the world. And they are quite similar to all energy efficient technologies that have faced throughout the last decades. It starts with lack of awareness, lack of regulatory support, lack of technical capacities, lack of right curricula or updated curricula in high schools and technical schools. Those are like Mr. Abdin has said, all components that comes together and hinders the development of those technologies in the countries. What CoolUp is trying to do is exactly to try and point on all these challenges on different aspects. We work with country governments to support regulatory development. We are working closely with Jordan government, and they are really committed and interested in the CoolUp project. We are really honored by their interest, and we are working on several different layers of regulatory update together with our local partner NERC. In addition, in all the partner countries that we have, as I said, will have an extensive capacity building program, not only targeting manufacturers and technical service providers, but also decision makers on the supply chain or the value chain of whole construction sector for air conditioning and refrigeration. This would obviously also include the commercial refrigeration purchase decision makers, which Mr. Abdin nicely highlighted. On the air conditioning sector, it also, of course, includes building mechanical engineers, architects, and system designers. Yeah, so we are going to work on all these aspects, and we have quite nice time ahead of us. Hopefully, we will see some acceleration by CoolUp input in the target countries. Thanks, Alex.
Yeah, thanks, Nation, for that answer. There is actually another question to Mr. Abdin, if you don't mind answering. It goes, in winter, is the CO2 system working on subcritical mode, or is it transcritical operation?
Subcritical, because in Jordan we have it in winter time, temperature could reach to 0 degrees C. So we will go into a subcritical mode. Yes.
And then there is another question for you. It is, can you share with us how R290 systems differ from CO2?
R290 have different applications than the CO2 applications. Of course, R290 is still a green gas or natural gas, I would say, but has a different application and a limited cooling capacity due to the limited charge into the chiller. But in terms of efficiency, in terms of green technology, it has a similar efficiency to CO2 system. When we speak of centralized cooling system, both are green, but have different properties. So we cannot really compare CO2 with a centralized system into R290 with a plug-in system. But we can say they are both green and natural gases.
There is another question for you, but I think you already answered it somehow. It is, what is the technical advantage of using natural refrigerants? How would utilizing CO2 reduce the energy consumption?
Yes, using it is first of all, it's a properties of gases, the efficiency of the gas, the boiling point, and as well using ejectors, where actually mainly energy saved by using ejectors into the system, where actually ejectors work as a compressor but without electrical motor. And that's why we say in summertime we are saving more energy, because ejectors are working more, they perform well with high ambient temperatures. That's where CO2 comes into, starts to save energy compared to the HFC's gases.
Good. Alex,
Thanks so much for the answer.
Alex, I can
Go ahead, Mr.
I can
Schulz.
underline it. Yeah. We have in between also in Europe, yeah, the higher temperature, the peaks in the summer, and therefore the resistance against the temperature for CO2 is definitely higher than for conventional systems. We have less problems, less technical problems when we have here also 38, 40 degree. Yeah, in Jordan it is standard, but in Germany 40 degree it is ultra hot. But the condition, also with the CO2 critical equipment, we will survive technically also such temperature by relatively constant electricity, but definitely we have less interruption of the equipment. And with the conventional, we have it more often. Therefore, I can only underline, Mr. Abdi, what you are saying from my experience.
Yes, actually, with our I would say limited experience with CO2 systems, since we have done only one system in Jordan, but we can see the durability and reliability of component used in manufacturing CO2 working equipments. Compressors are more reliable, are built in a very strong, reliable way. Electronic expansion valves, all component needed to be used in CO2 system is being done in a more reliable component than which we're using in HFCs. And HFCs are more into commercial equipment, have a limited life cycle, where we can see from CO2 system, from our experience, honestly, we have never ever been one time to maintain the system. We have never had one breakdown. We go just by ourselves. We have a program every 3 months just to go and clean the gas cooler from dust. That's all what we have done since day one of installing the system in this supermarket. And by the way, I remember it took us more than one, we speak about the difficulty of pushing natural or CO2 systems in our part of the world. It took us 1 year to convince this customer to install the system in his supermarket. Even he had not to pay a single penny. It was funded by UNIDO, and so the customer, he had to pay nothing, but it took us 1 year to convince him to let us install the system in his supermarket. One of the people came, 110 bar pressure in the system. It's a bomb in my store. It will explode. I said, nothing will explode. The gas, maybe people will be poisoned. People will die if explosion happens. Why explosion to happen? And then we have to involve Ministry of Environment to push and to convince the customers. The project was 1 year delay until we were able to implement it. And then we got another project to do in Tunisia, but it didn't go until now because the customer, he's afraid of something happened in his store, and then the program was cancelled. We more than 2 years it took us to try to convince a supermarket chain in Tunisia to install the same system as we have done in Jordan, but unfortunately it was rejected. People are afraid to go to the new technology, unfortunately.
Yeah, thanks so much. I think we have time for one last question, if I'm just looking on the time. It goes to Mr. Schulz. How expensive are subcritical CO2 systems compared to conventional?
So honest, this question I cannot answer, but only because my last subcritical system, what we installed in Metro, it was years ago. The 69 subcritical will be constant. There will not be more, in doubt less, but the transcritical will strongly increase. Now 153, and the end of next year we will have more than 200. But therefore, when I can answer transcritical versus conventional, in the beginning, honest, the transcritical were more expensive in the beginning. But in between, the whole industry moved. Nobody from us is asking what is a price comparison, because we are winning ever with the total cost of ownership. In the theoretical case, when the transcritical system is more expensive, some digit €1,000, we will win after few years with a lower energy demand, with a lower maintenance repair. In the end, I will take the arguments of Mr. Abdin. It could be in Jordan you have 30%, in Bulgaria only 20%, and in the Netherlands only 18% savings. But the savings are usually so high that we are winning ever during the life cycle, and not in year 15. We are winning in year 5, 6, 7. When we would have, it's only a potential higher cost for a TC system versus a conventional R448A or whatever system. I hope this answer is okay and reliable, but with subcritical, it is old-fashioned for me. I cannot say what is really happening.
And I would like to point that if they want to know the price, because we work with both systems, I know the price difference in between the two systems. The transcritical system is around 2 times higher in price than an HFC. If we take centralized cooling system with the same capacity of cooling, then transcritical is around 2 times higher in price than the standard HFC as well. Not just the system. We speak of maybe the gas, the CO2 is much cheaper as a gas, but again, if we speak of the piping, the special copper pipe are used in CO2 systems, which are more expensive. But if we speak in generally, once we made the calculation, how much or after how many years will the customer get his money back in investing on transcritical system, I would say around 4 to 5 years he will get his money back from energy saving, from food wastage. It will take 3 to 4 years. And let's say, taking into consideration the cost of energy in Jordan, the customer need around 4 years to get his money back, which is I wouldn't say it's a long period, because if we stick the lifetime of the system, it is usually 10 to 14 years. So you still have another 8 years to put money in his pocket, I would say, or to save money.
Yeah, thanks so much. So we see that there is a lot of interest, and I think it would be a good idea to do a dedicated, more technical session next time or in the near future. Don't you think, Nation, Barbara? Yeah. Unfortunately, we are approaching. Sorry, yeah, go ahead, Barbara.
Yes, I think that sharing these experiences, not just from EU, but also in the countries and throughout the world is actually key for people to pick up on technologies that are like maybe new to them at that very moment, but that are not new to the technical scene any longer. And that's like a really important awareness raising and information part I think we should support in the program.
Yeah, definitely. Unfortunately, we are approaching the end of our time together, so I'm afraid we have to bring this very interesting Q&A session to an end. I would like to thank all of our speakers for being with us today, and especially our guest speakers, Mr. Schulze and Mr. Abdin, for providing these super valuable insights of real-life examples. We really appreciate that you are taking the time to show us what is already going on out there in the businesses. Lastly, many thanks also to all of you in front of the screens for your interest in today's webinar and our work in Kulab. Before closing the webinar, I would like to point you to our social media channels. In addition to our website, coolupprogram.org, you can also find us on Twitter and YouTube, where we will post the recording of this webinar for those who could not make it today. And if you haven't already done so, we encourage you to sign up to our CoolUp newsletter. It's actually the best way to stay engaged and receive regular updates on our activities and events. And speaking of activities and events, CoolUp just published its first MENA region cooling status report, which shows progress, opportunities, and insights of sustainable cooling in the MENA region. You can easily find the report by clicking on the knowledge base on our website. Oh, and very soon we will also publish another series of reports, the cooling sector status reports. These reports focus on Egypt, Jordan, Lebanon, and Turkey and outline the current status of the cooling sector. So there is much more to come, and see you in the next webinar.